I guess we can kick it off. Sorry for the technical delays. We're actually doing something slightly different, slightly new today. So we actually have multiple streams going on. So you're seeing us on Crowdcast, and some people might be seeing us on YouTube. So I'm going to click this off. This is a global online meetup, and we're going to be celebrating our GA release of Harvester. So William, to the next slide, please. And this is an introduction. We'll have an introduction, Harvester GA overview, a quick demo, and then Q&A. Q&A with these things are, going to be fluid. Sometimes we'll pause the event itself and ask questions to these fine gentlemen as we go along. So don't feel free to ask questions. We are using Crowdcast, and if you are joining us through our private YouTube stream, there's a chat button in either one of these, and there is a question, ask a question section. Ask your question there, and we'll wrangle those questions up, and I'll be asking them, and then William and or Sheng will answer those for you. Next slide. My name is Robert Sirchia, and I am a senior technical evangelist here at SUSE. I am joined with our two distinguished speakers, William Jimenez. He's a technical product manager here at SUSE, and then Sheng Yang, which is the senior manager of container infrastructure. So these are our speakers. Sheng's going to be doing the demo. William's going to be going through our slides. I'm asking which slide. So William, next slide. All right, so this is not a webinar. This is a meetup. So those questions are very important. So we ask that if you're going to have a question, ask it. If you're in Crowdcast, there's an ask a question function in there. I'm monitoring chat here as well. Get those questions. We'll try to answer them as we go. If not, we'll get them towards the end. Next slide. This is very flexible. There's no bad questions. The demo hopefully will work. If the demo gods are on our side, but things do break. Be patient. We'll get them back online and we'll get things going. Next slide. And this, just as well as all of our global online meetups, this is being recorded. You can watch it here at Crowdcast once again, or you can watch it on our YouTube channel. Next slide. And we have two networks that you can join us and join the conversation. First is our Slack channel. It's 20,000 plus people in there. You can join the Slack channel, slack.rancher.io, and there's a channel dedicated to Harvester. Next slide. And lastly, we have our community site, which is community.suse.com, where you can ask a little more in-depth questions in there, find exclusive content, sign up to that community. Again, it's community.suse.com. Next slide. And William, the floor is yours, sir.
All right. Thanks, Robert. Appreciate it. Okay, so we're going to talk about Harvester today, specifically the GA. So we're really excited to announce our general availability of Harvester. It's been quite a while in the development, and it's exciting that we're here now in January 2022 to talk about what we're doing with Harvester as a GA product. So the inspiration for Harvester and the world that we're stepping into, this product, is a landscape of rapidly changing IT. Containers continue to be a fast-growing target for many enterprises. There's no sign of container adoption slowing down in the enterprise. Companies are continuing to invest heavily in greenfield, as well as lift and shift and rewrites onto container platforms of their key applications. So this is really big. Virtualized workloads are mature. This is a technology that's been around for a while now, yet virtualized workloads are continuing to see some growth and continuing to also show that they're going to have a place in the IT environment for the foreseeable future. Containers don't necessarily mean that we suddenly don't have virtualized workloads anymore. HCI, the hyperconverged market, is predicted to experience double-digit growth in the next 5 years. That's pretty incredible. And a lot of this is driven by the desire to have a more cloud-like experience on premise. And so when we think about what we get in the cloud, we get a very integrated, cohesive experience with all the components ready, storage, networking, compute, load balancing is all built in, and it's in a single API. People want the same thing in the cloud, or sorry, on premise as well. And so HCI is actually growing steadily, servicing both the container demand as well as the virtual machine demand. However, with all of this change, IT infrastructure is still very complex. It's increasingly more complex as people try to navigate the space. There's lots of room for improvement. And so, how do we navigate the complexity? Well, one thing we can do is look for ways that we can reduce the complexity from a technology standpoint, increasing efficiency and reliability. When we do that, we also increase TCO because we make it cheaper to operate and we remove more moving parts. Another thing we can do is look to modernize our approach to IT. Are we doing IT the same way that we did in the past, when the world was different, and should we revisit it? Is there a better way to approach how we deal with servers and compute and storage and networks? And then as well, we also see there's a drive to increase the skills and the talent pool that we have to work with, and using modern technologies as a way to attract the best talent that is going to help us modernize and improve our IT operations. And so here's where Harvester steps into the picture. So Harvester is an open source hyperconverged infrastructure solution. Now, what that means is it's an HCI solution, much like commercial HCIs that are proprietary on the market, but it's built entirely with open source technology instead of some new isolated technology that was built only for a specific by a specific vendor. So what we get is open source freedom and flexibility, the ability to customize, the ability to fork and innovate on, and to collaborate with other people in the community. We also get the freedom from licensing and hardware restriction. This means anyone can run it on any hardware, and you don't need a license to use it. And it has that freedom and that flexibility where you're not tied to a vendor right out the gate. It's a modern solution as well, and so part of what we think is very compelling about Harvester is a fresh look at HCI. HCI is a technology that was really engineered, over a decade ago or even 2 decades ago, and is technology that is really ripe for some rethinking and revisiting the problem statement with everything we know today about infrastructure and computing. So what we did with Harvester is we looked at what is available to us in the IT space, and Kubernetes and cloud native have a lot of innovation that can benefit HCI. It's benefited the container world. It came out of all that great innovation from large companies like Google and whatnot, for their container use case, but it can also benefit other people, can also benefit other constituencies in HCI. Harvester is a production-ready turnkey experience. So it's not an open source kit or framework that you build HCI on. It's designed to be turnkey, which means I plug it in and I get something that works, batteries included out of the box right away. I don't have to engineer a lot of work on top of it. It runs on bare metal, so you install it right onto servers. It includes the operating system, boots right up into bare metal, and then it forms a cluster. It's entirely software driven. So what this means is we don't require specialized hardware. A lot of HCI solutions, especially the first ones in the market, they required you to buy their hardware along with it. So the software was really a way to sell more hardware. And certainly at the time, there was benefits to that over what was available before. But we think the next step in the innovation journey is to decouple the hardware and the software together and really allow that competition, that natural competition of the commodity compute market, to help you arrive at your best infrastructure investment, and then couple that with the best in class software that we can offer you. And I think one thing that you'll find really exciting for Rancher users as well is the native integration with Rancher for containerized workloads. So this is really the game changer for someone who's trying to consolidate their complexity, and you'll see more about that in a bit. So why did we do this? Well, we wanted people to be able to modernize the entire infrastructure, not just their container platform. So we largely at SUSE Rancher focused, or especially Rancher, I should say, have really focused on solving container problems. And now that we've we've made some progress in the container world. We wanted to go outside of that domain and that problem set and try to address the larger challenge that IT operations faces, which is what about everything else that's not containerized? And with Harvester, you can actually bring cloud native tools and approaches like GitOps and immutable infrastructure and CI/CD and pets versus cattle, all these really great patterns and anti patterns in some cases. We can bring that thought into more than just our container applications. We also want people to be able to simplify their IT operations. So simplification is a key asset in the fight for site reliability. So when we're trying to make things more reliable and stable, removing complexity, removing points of failure, and consolidating visibility and consolidating control are powerful tools for increasing site reliability, as well as decreasing cost and overhead. And then finally, we really want to empower users to use the advanced infrastructure innovation that Rancher has developed in a broader scale. So when we think about Harvester, one of the exciting things, as I mentioned, is with Harvester now we get to include Rancher in the journey, and we get to expand Rancher's solvency beyond just the container world. And so we really like that now with Harvester. We've just added another layer to the kube cake, and so you can see down here now. Harvester plugs in and benefits from the rest of the great parts of our container ecosystem and continues to make the Rancher experience more valuable. So when you're running RKE on the data center or K3S on the edge, you can use Harvester as that infrastructure layer to complete the out-of-the-box experience. Now you've got a managed storage solution, managed networking solution, you've got compute management, all provided in a single system. So Rancher's approach to compute is something we're really very focused on. A lot of our success we feel is based on our focus on key values for how we approach compute and how we approach the problem of IT operations. And so a few of those things are things like multi-cluster. Right away in our journey, we realized that Kubernetes would be a multi-cluster endeavor, and we needed to be able to help people manage many clusters and not just assume everyone had one cluster. We realized that this would be a democratized world of Kubernetes distributions. And so the more that we embrace and the more we help people embrace and unify all their different distributions of Kubernetes, the better. The value and the need for our users is in Kubernetes management. So Kubernetes is becoming a commodity in the IT sphere, but managing Kubernetes and making it secure and making it stable and making it consistent is where the value is and where we need to help people. And open source needs to be primary and at the forefront to our approach. So these are kind of the key things that have shaped what Rancher has become, and is important to us when we think about how we solve IT problems. And it's fed into our approach of Harvester as well. And we really feel like we're actually continuing those initial goals to their fullest. We're actually fully realizing what we were trying to accomplish there when we add HCI and we add the virtual machine sphere to this picture as well, because now we're really recognizing it's a hybrid IT world, and all workloads are first-class citizens, even non-containerized workloads. And the more that we can manage infrastructure as a whole, containers, Kubernetes included, the more we can help our users be successful. And finally, that open source goal and that open source ethos, we're really excited to bring that into a new market where traditionally up until now, it's really been dominated by proprietary solutions. So we feel that it's time to sort of shine a new light on this world that has really been dominated and defined by proprietary closed source approaches. So one of the things people ask us a lot when approaching technology and approaching their IT solutions is, how can I modernize my applications, and how do I modernize my IT approach? And Rancher is typically a way to help with that journey. But up until now, it's only focused on the containers and Kubernetes side. And so when people are trying to figure out how to get to this container and Kubernetes world, not everything can be just rewritten in a short period of time. Not everything has the ability to be rewritten. Some applications need to stay in virtual machine format. And so we think that it's real progress that we can now offer Harvester and Rancher together to span both of these worlds, and provide a pathway for those legacy applications to be included in the cloud native journey. So now with Harvester, Rancher can help you manage those applications that are in that left side of the sphere that are maybe not containerized yet, but can now today benefit from cloud native technologies like cloud native monitoring and cloud native deployment patterns and infrastructure management and the storage technologies that we've seen in cloud native and that distributed infrastructure approach we get with Kubernetes. So that's really that's a big difference and a big change now today, for Rancher and for the way we approach infrastructure. When we zoom out and think about the deployment topology, um, in terms of thinking about the different ways that we deploy applications, in the IT world today, a couple decades ago, you'd be probably pretty normal if you had two or three data centers that you had to deploy your application to, perhaps a few regional data centers. If you're a US market, maybe you had an East Coast and a West Coast data center, and that was the majority of your deployment needs for your applications. And things have changed so much. Today there's it's not uncommon to have dozens of places that you have to deploy your applications. We're embracing public clouds, and we might deploy to multiple public cloud regions, and we still have some on-premise regional data centers. And so that can be several data centers or several deployments right there. And then you add the edge, and the edge just multiplies this even more if we're deploying to different points of presence for last mile CDN or content acceleration, or if we're deploying to retail centers or retail locations. Those could be hundreds of those, or manufacturing sites. So the landscape today that we have to work in IT is really different. And Kubernetes, we believe, has solved for a lot of this complexity by providing this single layer of abstraction across all these environments. So with Kubernetes, what I can do now is I can deploy to any of these locations and get the same deployment experience and the same use the same language for how I deployed all those environments. And this is where Harvester comes in, because when I get Kubernetes in these locations, in order to get to Kubernetes, it requires a lot of effort and a lot of integration. I have to think about the hypervisor, the storage, the operating system, the Kubernetes distribution, and I have to figure out which combination of all these technologies will work best and will be supported. Um, and and what Harvester does is it combines all those solutions together and provides a turnkey experience. So with Harvester, you don't have to worry about the integration of all those components. You can simply install Harvester onto your bare metal, and with a couple clicks, connect it to Rancher and deploy a Kubernetes cluster, and all of those concerns are integrated. And this is much like what we get in the public cloud. On the left here in public cloud, largely getting Kubernetes is a turnkey experience. I just go to Amazon or Google and I say, give me a Kubernetes cluster, and they set it up for me, and everything's integrated. The storage and virtualization and OS is all taken care of. And so that's what we wanted to try to do for the rest of the deployment landscape, is make it as easy as the cloud to deploy in the data center and the edge. Some of the use cases for SUSE Rancher and Harvester: building cloud native applications, modernizing and scaling infrastructure, re-architecting monoliths, and also the edge. I think these things are, they speak for themselves. There's many different ways that someone would use these things, but the key thing to take away is that Harvester is a way for cloud native workloads to be accelerated, as well as incorporating legacy applications into the cloud native space. So you've got kind of this double-edged sword that you get the benefit of. It's pushing your greenfield forward with your cloud native workloads, and it's also bringing forward your legacy or your non-containerized workloads. And it's 100% open source and community driven. Again, we're really pleased by this, and we're really excited to be able to offer this to a market that is traditionally not very open source. So we think this is going to give our users a lot of benefit. When we talk about what's in Harvester here, again, it's hyperconverged solution that's bridging the gap between cloud native and legacy. We also remove the need for you to depend on boutique SAN or HCI hardware, so you don't need any specialized hardware. This runs on commodity x86 hardware with local storage like SSD or NVMe. And when you plug Harvester on top of that hardware set, then you get an enterprise SAN, you get an enterprise virtualization platform, which creates an HCI solution for you. And so as you can see here, that Harvester is a turnkey solution. This is a view of our UI here on the right. You instantly get, when you install Harvester, you get to this UI, you instantly get access to things like virtual machine management and storage management and network management. And you'll find it's an intuitive experience, much like the other HCI solutions that you've probably worked with in the market. And then when we plug it into Rancher, then the ability to create Harvester clusters, to manage Harvester clusters from multiple locations is made available. So Harvester then becomes another cluster that Rancher manages, just like a Kubernetes cluster, but yet is a HCI and infrastructure level solution. So now Rancher is really managing container clusters and HCI VM clusters from a single pane of glass. And it's bringing all of the authentication and authorization experience that we expect of Rancher, all of that integration into Active Directory, and all that user management is brought into Harvester, as well as projects for isolating workloads and isolating users and groups within the environment. So we think this is something that our users will benefit from as well. And as I mentioned too, Harvester displaces the need for specialized hardware in the in the data center. And again, in that distributed, diverse world of deployments, not every point of presence is going to have that same SAN available or have the rack space for that SAN. So it's very freeing to not need to have that hardware there in advance. You can access any commodity hardware that you can find or is made available to you in those locations, and you can couple Harvester with that to get the complete solution. And again, mentioning our Harvester approach is 100% open source, and it will remain so for the future. All right, so that's the slides and the less interesting part. I want to hand over to Sheng Yang, who's going to talk about the more interesting things, which is looking at this in the wild.
Okay. And as we're bringing him up, are you guys okay with a couple questions, William?
Absolutely. Yeah.
All right. So, all right.
So should we have the question now, or?
Yeah. We can do a couple questions. Actually, here's one that can I try to run Harvester in a VM or in the cloud just to try it? And I know some people in the community have asked this, but getting it from your guys' perspective.
Yeah, so I think we definitely can use that. And also, like, just frankly speaking, some of our developers are using running Linux and running nested virtualization in the KVM, like for some lightweight Harvester control plane development.
Mm-hmm.
But though it might be hard to run that in your normal cloud provider, because Harvester, I'm going to demo it, and you will see it's going to be installed as ISO, which of course it doesn't have cloud image, those kind of type of format for you to use. So that's why it's like cloud provider might be hard, but if you want to have some bare metal servers and you want to run nested virtualization on that, yes, you can give a try and see the UI and maybe some very small workload on that, but that probably is. Yeah.
Okay. Egan has asked a question. We have vSphere in my workspace. Will Harvester work with vSphere? And I think it's more of an integration, less of that virtualization side of his question.
No. like
Yeah.
a harvester, like integrated with rancher, and also you will see that how rancher going to manage harvester in my demo later.
Okay. All right, let's do at least one or two more. Are rancher and harvester similar? Not getting the Venn diagram from the side. They're similar, but they do two different functions. But I think that's a question we can take offline. Let's just grab one more.
I can probably explain a little bit more on
Sure.
the demo. And the rancher, the major function for rancher is designed to manage multiple Kubernetes clusters. Of course, if you only have one Kubernetes cluster, it's also going to enable your experience much better by providing a very well-written UI and also a lot of add-on functionalities like CI/CD pipeline monitoring, those kind of stuff on your Kubernetes cluster. And the rancher is like before harvester rancher integration, rancher is really like only focused on the container, right? Manage your Kubernetes workload. And with harvester, it's really focusing on manage the VM workload, which is doesn't really have the same focusing as the rancher if you like manage a separate Kubernetes clusters through the rancher. But now rancher, like with introduction of harvester integration, rancher has become the unified management server, management platform for both VM on the containers, which I can demonstrate a little bit on that later.
All right, so there's two more questions. There's a rumor that Harvester will become a commercial product in the future. Are there plans to release an enterprise edition along with the community edition? I think this is more of a William question to answer. I think you touched on it.
Yeah, I can try. I hope I didn't suggest the wrong idea that it's going to become a closed source solution. Harvester is always going to be open source, but what we also want to do is provide enterprise grade support to make it as reliable and as usable by the enterprise as a commercial solution or as a proprietary solution. So I guess the right term would be it's commercial in that it's fully supportable,
right?
but it's open source and commercial, but not proprietary.
Gotcha.
So it's going to be similar to what rancher's model is. Like whenever, as a rancher user, you always get the same version you have, like compared to our enterprise customers, there's no version differences, right? You get the same thing. But of course, enterprise customers pay us to do the support in case something happens. So that's going to be the only difference.
All right, and one last question before we jump over to the demo. Any plans for ARM, V8, or 64-bit support? There's always the ARM question.
Well, I got asked about this a lot, but currently we don't have any concrete plan for ARM support yet. There's a lot of things in ARM virtualization we're still figuring out, and also there's other dependencies we need to work through. I'm very much interested in seeing ARM support because the components like the Longhorn, and I know KubeVirt has some support on ARM too, and there's some like many components like Meetup, Made Harvester Possible does have ARM support. So I'm looking forward to see what's the next step is, but there's currently no plan in our roadmap at this moment.
Okay. All right. We can hold some of these questions and jump over to the demo, Sheng, whenever you're ready.
Okay. Start sharing. Okay, do you see my screen?
We do.
Let me see if I can make it a little bit bigger or no, in fact, no. Okay, so as William mentioned, Harvester is the HCI solution, and that means you need to install Harvester on the bare metal nodes. So currently what you see is if you install the Harvester, like running Harvester ISO and boot it up via the ISO on your bare metal nodes, there you're going to like start installation process. You're going to face like two choices here. Either you want to create a new Harvester cluster, or you want this node to join an existing Harvester cluster. So this is the first node for this cluster. So I'm going to select create a new Harvester cluster here. And the next step, you're going to choose the device you're going to use for the creation. I'm going to choose a VDA, which has 200G here and some partition stuff, and set the harvester host name. And now you can select what's NIC, and we have only one NIC here. And once we select it, and also if you have multiple NICs, Harvester do support bounded NIC, and if that's the case, you can choose whatever bounded mode here. But if you only have one NIC, just keep it default. And I'm going to get IP address from DHCP server for this Harvester node. Just a side note that if you select to use a DHCP, it's better if you bound your MAC address in the DHCP server. Just make sure the node IP will not going to change, because like underneath, Harvester is powered by Kubernetes, and the Kubernetes IP, like node IP, is pretty much dedicated. You cannot really change them. Otherwise, you're going to cause a lot of trouble for yourself. Okay, so optional DHCP DNS server, we can skip this. And the Harvester also has a VIP, like a virtual IP config. And that is also like for this, in this case, you also get that from the DHCP, but you can also set like the static IP for that as well. So this VIP we're going to be used to access the Harvester UI and also join new nodes in the future. So you need to define a cluster token here. It's more like a password for any future node to be joining. They have to provide the same token. Let's go with the demo here and put some password, and you can use this to access the node. And NTP server setup. Proxy, SSH remote config, there's some advanced config, and you can find out more in the Harvester document at docs.harvesterhci.io. So with all that down, I'm just going to click just start in formatting disk and start install Harvester. Okay, so I'm going to skip this part. And here is in fact a Harvester cluster I already like installed. You can see that once you're, let me show you how, yeah. So if you just get into the Harvester the first time, you're going to see, you are going to given a IP address in your console, and if you put that IP address in your web browser, you should be able to reach this interface. And I'm going to put username password here to log into the Harvester. And the first page you'll see right now is the dashboard. And you can see that we have 6 hosts here, and the certain virtual machines, 22 volumes, and those kind of overview. And also you will see that what's the whole cluster's capacity. And just noted that I got asked a lot of questions about this, why the overhead is so big. So this is reserved for the Harvester system use, and is by default is set about like 25 to 30%, and that is only for, say, it's not going to be, it's not a real-time usage, it's just in case. Just make sure the system level components like storage and monitoring and those working well. So if you want to take a look at the real-time system usage, in fact, you can find it in the dashboard down here. We have cluster level metrics, and you can select for last 1 hour or like last 6 hours. We have some outage here. Yeah. So, and also the VM metrics, and you can see more details on how each VM is doing in this cluster as well. And those is all building functionality and come with once you install the Harvester. And down here, you are going to see like a little bit more on what's the current event and the VMs, and also image and the volume. There's not much to see here. Okay, let's go back to the host. The next tab you'll see is the host page, and there we're going to list all the hosts you have for this cluster. And if you click into one of them, and you can see the basic overview for the host, and including the host IP, and also like how the CPU and the memory, and as well as what are virtual machines running on this host at this moment, and the network and the disk situation. So Harvester also support multiple disks. You can add disk in this page. if you have like, of course, disk attached to to your host, and you can just add the config and put on the disk and add a disk, and well, nothing can be selected right now because every disk available has been already selected. Okay, so that's on the host page. And everybody probably care the most is the virtualization, the VM page, right? So here we are separate the VM into namespaces, and you can see we have two namespaces here. One is called the default, another one is for the rancher server, which I'm going to cover later. And to create a VM, you can always click create. Yeah, that's pretty much straightforward. I'm going to select which namespace I'm going to put that into, and put a name here, and like I give you like 2 CPUs, 4 GB memory, and you can select the volume, which is preloaded image, and I can select like OpenSUSE here, and this volume size is 10 G, and also it's fully customizable. And on the network side, I'm going to put this VM in the management network, but also, in fact, you have choices to set multiple network, and the other type of network we support at this moment is VLAN networking, and that VLAN 91 is also pre-created with the VLAN ID 91. So I'm going to put this VM in these 2 networks, and the node scheduling has some more advanced scheduling policy you can define. And another advanced option is most likely when you do a cloud image using Cloud OS image, you want to configure the cloud config. And I'm going to put the default password here so I can log in. And also the network data and SUSE, this is like basically network cloud config. So I'm going to have 2 NICs here. And down here, well, USB tablet is for those OS like you want to have like a UI access, and this one going to make your mouse pointer much more accurate. This is a Linux, so we don't need that, but we do need a guest agent, and that is going to add a few things in the user data and to make sure that guest agent will be enabled correctly for this OSS, for this VM as well. So everything's down. Let's click create. So while this VM is being created, and we can take a look at, once you take a look at what is I have created before. So you have 2 ways to access your VM, and one is opening the VNC console. Yeah, so of course I have checked it beforehand, just make sure everything works smoothly. And I just put the username password here, and you can see this one I previously created. It only have like 1 interface, but this is like able to ping to the Google because it's like we configure the traffic to be like, of course, this is determined by your switch and your network layout. And the other thing I want to show you here is if you want to have a like the serial port access, and you can in fact go through the serial port here as well. Okay, I think this VM might have serial port disabled or something. Okay, let me try this one. Yeah, you can see from the serial port there's information coming up because this VM is still in the boot up period, and have the output some information in the serial port directly. So let's wait for this to be done. And in fact, let's go back to the VNC console to check if this one really have the 2 NICs we asked it for. Yes. So you can see this VM has been created with the EASY1 and EASY0 and EASY1 2 NICs. And EASY1 is in fact on the 91 VLAN because the INET, you can see the IP address is it got assigned to is 172.16.91.31, which is in the 91 network. Okay, so this one has booted up. All right. So in fact, you might notice that previously I gave you a demo on the installer, and this installer demo is in fact the VM running on the Harvester, and well, it's still ongoing at this moment. Okay, so I have another few things I want to show up. The one thing is there are people asking if you can run Windows on Harvester. The answer is of course you can. You need some virtual driver, and we have that more in detail in our documentation. But this is running. Yeah, in fact, what's the password here? Okay. Yeah, this is running the Windows Server 2012 R2 version, and you can also see the network should be fine. Let me see if I can. Well, using really outdated browser here. Get Google. Yes, I can trust it. All right, so that's this on Windows, a quick demo, and let's go through a few other things once we have the VM up. So in the VM page, yeah, you can see the configuration, everything here. And if you modify the configuration, you still need to reboot. And on the volume, network, SSH, I haven't put anything here. And also the VM metrics is going to give you overview that what is the info this VM, and that is the reported part by the agent inside the VM as well as also the hypervisor. So cloud config is what we have said before, and the events, we can see that the whole process of the starting the VM and in here as well. And if you are familiar with Kubernetes, you can see that the whole event is more like in the Kubernetes style, but it doesn't really require you to understand Kubernetes to get a VM and your network and the volume sorted out. Okay, so do we have any questions so far, Robert?
Actually, you got a lot of questions in here, so I'm going to start going through them. I think we got 20, 21, 22 questions.
Okay.
So let's just kind of roll through these if you don't mind.
Yeah, no problem.
Does Harvester support GPU functionality?
Yeah, GPU pass-through is the one thing we have in our roadmap, and yeah, we are going to support that in the future. It's not supported right now for the 1.0 release. Okay.
Let me mark as red here. Let's see what else we got here. Is Rancher required to manage multiple deployments of Harvester?
So, if you want to manage multiple deployments of Harvester in a central place, yes, Rancher is required. If you if you're fine with logging into each Harvester cluster to manage that cluster, yeah, then Rancher is not required.
Okay, so if you want the centralized location for it, Rancher is obviously required. But if that's not a requirement and you want to do it the old-fashioned way and log into each one, okay. With that being said, how well does that scale? I mean, how far can Harvester scale with the Rancher tying into it?
For the Harvester cluster itself, at least we try some. I don't have detailed data right now, and but maybe we need to do more stress testing, for example, putting 100 cluster on there and seeing how things goes. Yeah.
Okay. We have a couple questions on storage and how is storage handled, like vSAN or Nutanix storage. Can you kind of expand on that a little bit?
Yeah, so storage part is powered by Longhorn, which is the CNCF incubation project, and that was also originally from Rancher as well. And you can see, in fact, there are many features here. It's a little bit hidden, but if you take look at the image feature, we allow you to upload any images either from your local desktop or just put the URL here. And in fact, in the back, Longhorn have a feature called the back image, and that is supporting this image management feature. And that also means whenever you're creating a new VM, if that node already have the same image underneath, Longhorn is only going to create a thin layer on top of the base image, the back image, and then that is greatly reduce your storage consumption. So, and also another thing Longhorn supported here is if you want to do a live migration to another node, And that is like not easy if you don't have a storage solution like supports that. And there's not much out of box. You can do that in an open source way, but the Longhorn supports live migration as well.
Okay, awesome. And that's live migration supported through Longhorn, correct? Not
Yes.
Harvester.
Yeah, because Harvester itself, the virtualization part, when you do the live migration, you need to, the most important thing, like 2 states. One state is your memory, another state is your hard drive. So you have to have those 2 like migrated over to the new location. So the memory part has been taken care of KubeVirt, which Harvester using for the virtualization management. And the hard drive part is taken care of Longhorn. We're not copying the data over for sure. We only have underneath Longhorn start another engine, if you're familiar with Longhorn concept, on the other node to have access into the data. Just make sure the data can be smoothly converted over. So let's in fact just take a look and see. This one should be fine.
Okay. And is Harvester still based on K3s?
Harvester is based off the base experimental Kubernetes distro has been changed from K3s into RK2, which is more have more enterprise grade features. So that's the Harvester now. The baseline Kubernetes distro using by Harvester is RK2, but it shouldn't really concern the user because the user experience exposed by the Harvester is the same.
Okay. Does the management host need to be fully spec'd as a worker host, i.e. non-management hosts? So 32 gigs plus seems to be a waste of RAM for a management host. I'm not sure if we call them hosts.
We don't really have a distinguish between the management host and the worker node. And you can see that we have 6 hosts here. And in fact, 3 of them are management hosts, which are the first 3, but we still running VM on top of that. And that's fine. That's by design. So basically what happens is if you install Harvester on one node, of course, that node we're going to serve as both management node and also the worker. And once you install 3 nodes, you have 3 nodes in the cluster, Harvester going to automatically promote the 2 other nodes into the management role. So you're going to have a highly available function, and also you still can run workload on them. And if you further scales up, and that 3 nodes will continue to be there. And if one of those nodes is bad and you remove them, Harvester can automatically pick another node and promote that to the management node as well. So it's a more transparent way. It's not going to be really have a big impact on the user.
So a solid question here. With all the automation, other toolings available for Kubernetes out there for troubleshooting and monitoring, are these available for Harvester as well since it's based on Kubernetes?
Yes. So when you do the troubleshooting or explore some features not supported by Harvester, yes. In the end, this is Kubernetes, and underneath you're running on Kubernetes. One caveat is as a supported form, we don't recommend running workload on the bare metal Kubernetes layer because that might mess up with some calculation as internals for the Harvester. But if you want to do the troubleshooting, you can access the Kubernetes by click support. And the one thing you can do is generate support bundle, which is you can upload to the Harvester Slack channel or GitHub issue and to help the engineer to debug. Another one is, in fact, you can download the kube config from here if you know your way in the Kubernetes.
Awesome. All right. So here's a question that even I had earlier. And it says here, I believe it's installing COS, which I believe is the COS toolkit. Does this correspond to OpenSUSE Leap 15.3? So if you guys want to kind of expound on that one.
Yeah, so currently the kernel we are using is the kernel of OpenSUSE 15 SP3. Yeah.
Okay.
And but COS has like we put a lot of like modification on that, so I'm not going to call it like really just open leap because it's not really 100% like OpenSUSE leap. Yeah. So William, do you want to expand on that?
I think the question is when you install Harvester, you understand that you can see that it's installing the CLS toolkit, and that's not necessarily the same as OpenSUSE Leap. It's similar, it has similar components, but that's the operating system underneath. But it's not OpenSUSE Leap. Is that correct?
Yes, I think that's right.
Yeah, we take a kernel from OpenSUSE and then we layer on top of it as needed for Harvester. So as Sheng said, it wouldn't be fair to call it the same thing as OpenSUSE Leap in its entirety. It's really a customized operating system for embedded use only.
All right, here's a good question here. Currently, I use Terraform to provision VMs or create network in OpenStack/VMware. Can we achieve the same Harvester functionality with Terraform?
Yes, in fact, Harvester has the Terraform provider as well. We wrote Terraform provider as well. Yeah.
Awesome. We're just going through these questions.
Great questions, though.
All right. Let's see. Here's a great one. Is Harvester a multi-node solution, or will it work on a single node too? And then what's the disadvantages for that?
Harvester definitely work on a single node, and we basically designed to scale from one node to like your whole data center, so that if you only have the single node, the disadvantage will be if you lost that node, you lost everything.
Mhm.
But once you have like 3 nodes, like Harvester will set up the highly available HA cluster like automatically, so you can like lost one node, like at least lost one node will be fine.
All right. So I think we mentioned it earlier, but here's a question to it. What kernel is it based on, asking for context for hardware support? So you're confirming the kernel is OpenSUSE 15.3?
Yeah. So kernel is indeed OpenSUSE 15.3.
Yeah, and as far as hardware support goes, you can look at the SLES 15 hardware support matrix, and Harvester expects to have similar compatibility with anything that the SLES platform has compatibility with. We have a deep list of partners and hardware partners that we've integrated and tested with on the SLES side that we're platforming into this.
Okay. All right. Is Harvester running on any Linux distro, or does it come with its own? I think we talked about that. And does the operating system need to be managed for Harvester, or need to be managed separately? And I think that kind of comes down to, if it's the COS toolkit as an underlying operating system, what manages that outside of Harvester?
Yeah, so operating system is a part of Harvester, so it's going to be managed by Harvester itself.
Okay.
Yeah. It's an embedded operating system.
Let's see here. Does Harvester use KubeVirt to launch VMs, and how difficult is it to transition from OpenStack to Rancher/Harvester? I think that's a big
so
question.
I got the first question is Harvester is indeed using KubeVirt to launch VMs. We have also have very close relationship with the KubeVirt upstream community, and to adding features and fix bugs in KubeVirt as well. And well, so for the second question, I don't really have much experience on the OpenShift with VM, so I probably cannot answer that.
There's an open source project.
Try.
Yeah, there's an open source project called Forklift, and I believe it can migrate out of OpenShift into the format that Harvester understands. So you might want to check that out.
That's Forklift. All right. Can we customize the dashboard using Prometheus queries integrated with Grafana? I think they saw a link to that.
Yes.
Okay.
If you take a look at the dashboard, this is a button Grafana. And yeah, feel free to do whatever you can with Grafana here. Yeah. Any other questions?
So here's another one. I saw a link to Grafana Harvester run a Grafana instance. That's you're confirming that?
Yes.
Okay. Awesome.
And Prometheus, right?
Yeah. Just the monitoring solution is provided by Prometheus underneath.
All right. All right. And this is an interesting question. If a 6-node cluster lost one management node, would a worker be promoted to management node automatically with Harvester?
It's not going to do that like in the sense of automatically if the previous node is still in the cluster. So you need to remove the node you know is gone. It's really like gone. And you need to remove that node from the host page. And then Harvester will going to promote another node.
All right. Mick Pollard, Mick, glad to see you. Mick and I crossed paths in an earlier life. And he has a question. There is 2 networks, management and VLAN. What if I want a VM on the management VLAN? Is that possible?
Sorry. So I need some clarification on the question. So do you mean that you only want the VM on the management network rather than the VLAN network?
Correct.
Yeah, that's definitely fine. So in fact,
that's default, right?
Yeah, that's just the default value. You can see that this OpenSUSE demo VM, it has only one network, like management network.
Awesome. All right. If you guys wonder what I'm doing, actually, I'm scrolling through all these questions and making sure I ask the ones that are highly voted, but I have to say that they're done and answered. Here's one that's out there. Do we have an ROI comparison between Harvester and Rancher versus AWS and their managed K8s, version? So do we have any ROI numbers to what that looks like?
I feel like that might not be the best comparison. I think there's some alignment there in some ways, but
sure,
you probably want to isolate the variables a little more to make a fair comparison.
It's kind of apples and oranges, right?
Yeah.
Okay.
It's all in the citrus family, but yeah, not the same.
So limes and lemons.
Yeah, maybe, yeah.
Is Harvester a good substitute or alternative for OpenStack?
It's probably more close to like VMware SSI, like vSphere or Nutanix than to OpenStack, because OpenStack is it's a little bit about one layer above, which is like they can manage multiple VM providers and have very complicated network model like VPC and very complicated storage model on top of that as well. So, but if you are just using OpenStack to run VMs in a simpler network, and now current Harvester can do that, and also like in the future we are looking into like enhancing the network part as well. But it's going to be a question if we are going to provide a VNC or not. Like sorry, not VNC, like a VPC or not.
Okay.
We actually have several prospects who are looking at Harvester closely to replace OpenStack, but they're using limited function of OpenStack to begin with. They don't depend on all of OpenStack's features. So it really depends on what the use case is.
All right, so here's 2 questions I'm going to ask kind of back to back because they're very similar. What exactly happened when with a Harvester when a node dies? And then the other one is, so with 6 nodes, how many can you lose without workload disruption? So it's kind of like a load balancing scaling thing.
Yeah. So underneath the Harvester, there are 2 parts of HA. One is on the control plane, another one is on the data plane. So the control plane is the traditional Kubernetes powered. So it's going to be out of 3 control plane nodes, you can at most afford to lose 1. So if you determine that one is lost, you better like remove that, and the Harvester is going to promote another one doing the replication in the backend city. So that is on the control plane. So if you are on the worker, like for the worker nodes, like the underlying data replication is done by Longhorn with a replication factor like replicas of 3. So that means you can at most lose 2 nodes. If you happens that those 3 nodes holding the data for the same VM, you can lose 2 of them and without any impact. So that is the basically the fault tolerance and for given VM. But if you consider if you have the VM and your storage across different nodes, and so that's going to be more on the case by case. As long as you're not losing 2 replica, all 3 replicas of a certain VM, you'll be fine.
Awesome.
Okay, so in fact, I still have something to demo, and I'm not done yet. So let me go ahead and finish my demo first. I didn't expect so many questions at this moment, but let me see how this one doing. Okay, so in fact, this harvester we installed before is being up and running, and is at 91.27. And you see, one interesting you see that here, the IP address for this VM is in fact 91.78. But the one thing, once you have the harvester installed and running, you will see 91.27, which in fact is the floating virtual IP, and for the harvester. So let me see what happens once we got into that. 27. Yeah, so let me just put some new password, and this is the first time you get into the harvester cluster, and it's going to ask you to send new password. Oh, all right. And now we are loading the harvester on harvester, and it seems we don't have enough memory to load in the graph yet. And you can still see that we have virtual machine, that's everything class is up, and this is just single cluster, in fact, running on my previously 6-node harvester cluster as nested visualization at this moment. Okay, so let me go through the other items we have. And so the volume in this page, you can still see the volumes, the hard drive, the drives using by the VMs. And the image base and the image page, you have seen what we have demoed before, and you can directly upload the image or specify URL for the harvester to download it from the internet directly. On the namespace, you can create more namespace to manage your VMs. And on the template side, and we have 3 building templates. One is for the ISO, another one is for the raw image, and the third one for Windows, which contains our virtual driver for the Windows as well. On the backup, so we haven't set up the backup yet, but the harvester do have built-in functionality to back up your virtual machine to the S3 or NFS server once you set that up. On network part, we have the VLAN 91 set it up here. You can create more just by adding, I think we also have VLAN 92, and of course, this is highly subject to your switch configuration. Okay, SS keys, I think I have my key here, and cloud config template is help you to shortcut your cloud config setup for your for your user data and also network data part. So one thing, in fact, here. Yeah, so one thing you notice that I have another Rancher server running inside Harvester, and this Rancher server with this IP, and then we can access this Rancher server. And in fact, this Rancher server is managing Harvester, through the virtualization management page, and you can import existing Harvester class here. And what you need to do is, I click create here, and here you have a registration URL, and you can go to the Harvester setting, and around here it is a class registration URL, and just paste the URL here. As long as Harvester can talk to that Rancher server, and this Harvester class will be registered into the Rancher server. And of course, this one, like we're not doing anything about that, so I'm going to remove that for now. And once you register your Harvest cluster, you can get into the Harvester dashboard using Rancher as well, which you see like this is a little bit different from what you can see here. Yeah, of course. Right, so you can see here we have a dashboard, and we don't have a hamburger menu here, but once the harvester running and managed by the rancher, and in fact this is more like a UI redirection plus some enhancement feature like RBAC, and now you can create a new cluster member to subject to certain RBAC rules, and also you can create new projects, and not like in addition to the namespaces. So those features are like added once you have the Rancher integration, and also we provide authentication as well through Rancher. So, but for the virtual machines and everything is going to look the same. And of course, as if you take a look at the reason why you want Rancher to manage Harvester, one thing is for like central management for all your Harvest clusters. Another one is, of course, you want to spin off Kubernetes cluster on that. So you can see that I have created 2 classes in here. One is RKE1, another one is RKE2. And a word of warning here, like RKE2 at this moment is still an experimental feature, so that's why you see some issue with it. But the cluster itself is pretty much well running at this moment. And you can see that those are 3 node RKE2 nodes we created. On the Harvest side, you can also see those nodes, like on the virtual machine. What's this? Here, those 3 nodes. So if you are using Rancher provision the Harvest Kubernetes cluster on top of Harvester, on the RKE2 side, we are going to automatically install Harvester Cloud Provider and the CSI driver for you. That means you have the full Cloud Provider load balancer plus your persistent storage support. So here I have deployed WordPress app in this cluster just for example. So once you deploy this WordPress app, and you can see the WordPress app has exposed a load balancer in service, and this one. And this you already get the IP, and you can in fact access the WordPress using this IP, right? This is IP getting from the cloud provider on the developmental node. And also you can see on the storage side, once you install Harvester, and you are going to see the Harvester in the storage class. And on the currently 1.0 release, you does need to set the default manually. That's one thing we're going to fix in the next patch release. And though once you have the storage class set and start using the storage class, the persistent volume claims we're going to create persistent volume automatically for any usage of your storage inside this cluster. And this persistent volume and the storage class is in fact powered by the developmental level storage. As you can see, now we have those volumes. And you can see those are like, we have the PVC here. And that is we using our CSI driver to offer you the storage like directly attached to the hot plug into the virtual machine for you to use with those within the your Kubernetes node for your Kubernetes workload. Okay, so on RKE1 side, and RKE1 also have all the functionality available. And though a little bit difference is you need to get into the chart and install Harvest Cloud Provider and Harvest CSI driver manually to get those features for the Harvest Cloud Provider and CSI support. Okay, so that is most on the Rancher integration part. And also another thing I do want to just emphasize is once you have the Rancher integration, we support all the authentication, all the auth provider Rancher supported, and also you can add new users here and then grant its permission to a certain Harvest cluster, and then you can do it really detailed RBAC rules control for the Harvest cluster as well. Okay, Okay, so that basically concludes my demo. Any questions?
Oh yeah, we got a ton of them here. All right, so we had someone emailing a handful of questions. This is from someone on our other stream, and it says, and the question is: Harvester is and can be a standalone HCI solution deployed using Kubernetes as its backbone. And he's asking, he's assuming that we're using KVM as a backend for that. Is that correct?
Yes, we're using KVM, and yeah, so that's because the virtualization management is using KubeVirt, and that is based on the KVM. Yeah, so in the end, the hypervisor is the KVM. But Harvester, one thing I want to emphasize is Harvester cannot be used on top of your existing Kubernetes cluster. So the only way we support this HCI solution is to install it on the bare metal. So on the very, very early days, like 1 year ago, we do have something say you can install it with a Helm chart, but that is proved to be like too difficult to manage the dependency and the support. So we decided to just go with the HCI and focus on our efforts on making this experience the best.
Okay. And I think you touched on this before, but I think they're looking for some clarity. In Rancher is an application deployed on top of Harvester to manage multiple deployments of Harvester. Is that correct? And I believe you did answer that.
The Rancher in my demo, Rancher server is deployed on top of Harvester, but like it's up to you, right? So first, like this Rancher server is a single Docker run command. You are not going to really like. If you want to run a production workload, you have to at least have 3 nodes to run a Rancher HA setup. And that setup can live in the Harvester or outside the Harvester. And if you are using a central Rancher server to manage multiple Harvester clusters, my recommendation is have a dedicated Rancher setup, maybe outside the Harvester, so it's not going to interfere with like the underneath Harvester as well.
Okay. Here's a very popular question. How is Harvester updated? Do we wait for new Harvester releases and upgrade in place, or will it be updated through repos as per OpenSUSE/SLES?
So it's going to be updated by the new Harvester release. So currently, 1.0 GA is the first Harvester release, so it's not going to be an upgrade like to the 1.0 at this moment. And we have some way to upgrade from 0.3 to 1.0, but it's proved to be like probably a little bit too complicated. From 1.0 above, and once a new Harvester version released, it will be released as ISO. And we'll provide a way for you to upload this ISO into the Harvester. And then we are going to kick off the upgrade process, like just doing like, for example, just basically like briefly describe it. It's going to be a rolling upgrade per node, and we're going to upgrade the current like the OS on each node, and then like upgrade next one, and move things around the line migration. Migrate your VM, just make sure they are stay alive, and then once everything down, we're going to upgrade on the Harvester and the Longhorn and those components.
Okay, so there's another question here that I want to get to. There are a number of additional packages that I would like to install to the base operating system. Is mounted RO, so how to do that? So I think what Don is trying to think is he needs to run OpenSC, SCAP, and other security hardening tools. How do they do that on the Harvester CLS?
Yeah, so the CLS is, as you already noticed, CLS designed to be read-only. So if you have any like specific requirement on running something in the base OS on production, I would recommend like file the issue, and we are going to look into if we can including that in our distribution, right? So you can like in theory you can unlock the root partition and make it rewrite and do whatever you want with it. But once you upgrade that, all that will be lost.
Okay. So Don Thornton, if you want, it's a GitHub issue. So just file it there, and they can take a look at that. That's a good question. Scrolling up here, what are some of the bigger things in the mid to long term roadmap for Harvester? That's a great question.
Yeah, so a few things we have right now is we want to have a single root IOV support and also the GPU support as well. In fact, let me just open that roadmap.
That's what many people forget. It's being open source. You can actually open it up and see it.
Okay. All right. Okay, so now I can just go by list. Like the next version, like currently Harvester support backup to the backup store, but we don't support the in-place snapshot and revert at this moment, and that is our target for the 1.1 release. And the VM clone is, I still think we have some kind of support, but we do need to enhance that. Yes, we do have clone, but we do need to enhance the usability there. And we are looking to have the log connection and export and even recording feature as well. And some other things like support simultaneous migration from other virtualization platforms and how to restore Harvester VM into a new Harvester cluster, and as well as the enhanced Windows experience, which is the one thing like we really want to put more effort on to make sure that the Windows community has good experience with the Harvester VM as well. On the future roadmap, we have GPU pass-through, which I mentioned before, and we want to simplify the container to VM network communication and also VXLAN support. And having like previously, I mentioned that we probably want to have like 100 or 1,000 Harvester cluster to see that if they can manage by a single rancher instance or like Azure setup, and that is one thing we want to do as well. And on the network enhancements, we are looking forward to have including more telco or like enterprise-grade network solutions rather than just have the VLAN here.
Awesome. And then here's a question that was voted up. Does Harvester support API to manage the VM lifecycle?
Yeah, so Harvester's API is in fact Kubernetes API. So once you have the kube config, you can indeed operate Harvester API like the CRs objects to manage the lifecycle. There, we are working on an API reference guide and also provide some use scenarios to manage Harvester VMs through the API as well.
All right. Does Fleet and Rancher also manage application deployments in the Harvester guest clusters as well?
Yeah. So if this guest cluster in the Harvester, yes, please manage that because that's just Kubernetes management. And we are also looking into how to integrate Fleet to maybe manage Harvester host developmental cluster as well. But that's something like we need to look into.
Okay. Let's see. Is there a cloud init support for VMs?
Oh yeah, so those are cloud config.
I think you demoed that actually.
Yeah. So you can see like in fact those images I got is cloud init supported. This is like one cloud image. This is open source cloud image as well. Yeah.
All right. What is the SDN solution used for Harvester?
So currently, we like our network solution is pretty straightforward. One thing is, of course, Kubernetes management network. We can like Kubernetes overlay network, which is called management network in the Harvester, and you can add it to any VMs, and that is the like most default setup. And also, you can have a VLAN set it up, and once you connect your switch correctly, you can have a VLAN set it up and add to the VM as well. One VM can take multiple networks, and that is thanks to our components motors.
And to follow up with that, Don Thornton asks here, what about the bridge network issue?
What about bridge network issue?
I'll give him a moment to expand on it. Don, can you expand on that bridge network issue? And while we'll give him a moment, a question came in. Can you demonstrate how to deploy a VM using that API?
I don't have that right now.
Okay.
Yeah, but as I mentioned, that we are going to have so first we have internal end-to-end test framework, which is 100% using API driven to try to testing, deploying VM and all the functionalities. And also we are writing up API reference guide, including the VM deployment and the common scenarios to see like those are the calls you need to make to have the action happen.
Okay. All right. Here's a question came in, and I think you touched on it, but I want to see if we can get it off the list here. Is how does Harvester differ from some of the other HCIs? Now, there wasn't a one for one comparison with OpenStack, but if you wanted to put it up against, I don't know, vSphere possible or ESXi possible, and how does Harvester? What's that differentiator?
Yeah. So one thing is Harvester is 100% open source. You can even see our development process in GitHub as well. There's no, it's open source. Is you can open to use it, and I would love to have your feedback. And that is one thing. Another thing is Harvester is in fact like building on open source cloud native technology as well. As you know, like the baseline is the Kubernetes, and we really provide this well-known open source API for you to operate on that. And another thing I do want to point out is Harvester is young. It's much young compared to like 10, 15 years VMware or like 10 years Nutanix. And those are most comparable to the Harvester, but there's no way, like at this moment, the functionality is going to be up to their technology accumulation over the years. But the question is, what do you need HCI for, right? So if you want to have the HCI for the simple management for your VMs or running your Kubernetes cluster in your data center, and Harvester provides all the functionality you need, and plus the integration with Rancher to give you first-class experience with your Kubernetes management. So that is really the strength, the target, like for the Harvester. So of course we are still expanding, and we are also enhance the product to have a well prioritized features and to enhance the experience on that as well. But at this moment, if you can give Harvester a try and tell us what you think, and do you like it, do you hate it, and why do you hate it, right? So if that's the case, so that's going to be a great help for us to fully like further go down the line to invest in this open source technology, and we do see a huge potential. And we also have like customer like using this at this moment, and they also love it.
Okay. All right. So we're going to jump over to a quick question. Is it possible to see the Longhorn UI for Harvester for local storage?
Yes, you can. Okay, so yeah, you can. And I need to put a disclaimer here. The things I'm going to show right now is only for debugging purpose. Do not operate on your own, and the Rancher or SUSE are not going to take any responsibility if you get something wrong. Okay.
Don't try this at home, kids.
Don't try that at home. Here you are. So this is the familiar Longhorn UI, if this Longhorn is familiar to you, and the volume and what everything is here. Yep. And in fact, if you take a look, you'll see that this is in fact Rancher UI as well. This is also only for debugging purpose, and we don't support deploying applications workloads in this UI as well. So, but you can, if you want just for the debugging and the troubleshooting, that's going to help as well. Okay, let's go back to Harvester.
Are we running out of questions?
No, actually, Don came back here and says here, and he clarified his question. So VMs are only connected to the VLANs, and the Open Bridge network, which is BR0, does not work and thus requires implementing VLAN network at the switch.
Yes. Yes, that's one thing about VLAN is if you're comfortable with VLAN configuration at the switch, you'll feel at home. If you're more comfortable like without the VLAN, don't need to configuration the switch. That is why we have the VX line in the roadmap as well.
Okay. So that clarifies his question. Let's see. Can we get Harvester added as a topic to the community so we can tag our posts accordingly? Simon, I will do that. That's not on these fine gentlemen. That's on me. You could have just DM'd me that one. But yes, I can take care of that. And here's a question from Dash is how can we send our metrics data to our Grafana installation in our data center? And I think this is outsourcing the metrics from Harvester to a offsite, or not necessarily offsite, but outside of the cluster Grafana.
Yeah, we haven't looked into that. Yeah, we'll work on a feature request, and we should able to expose some kind of endpoint on the Harvest side for that.
Okay. Answered. Scroll down, make sure I'm not missing one last question, and then we can ramp up because we are actually coming up to time, so we're going to be a minute or two over. How do you update the components? Have seen something on the settings, but don't know the procedures. Mariano, that might be a question to ask the community. We can jump back because I think it's a little deeper than that, but I want to give Sheng an opportunity here.
Yeah, so Harvester, I want you to see Harvester as a whole. So the whole upgrade process is going to be managed by the Harvester. Of course, underneath they have separate components, but we don't really recommend you to upgrade them separately. And once we have the new version, Harvester, for example, 101 coming out, we're going to provide upgrade instruction for you to upgrade Harvester.
Awesome. And we did it. We actually got through all of our questions. So we can ramp up, but I want to first thank everybody for coming. We appreciate it. This is a global online meetup. It's one that we're excited for. My enthusiasm was noted by William earlier. So thank you, everybody. William, Sheng, thank you for coming and hosting and presenting and talking about Harvester.
Thanks, everyone.
Thank you. And if you haven't joined, click the green button on the link below in Crowdcast and join the SUSE Rancher community. You can do that by signing up at SUSE or community.suse.com and join us for some of the other events. We have one coming up on our global online meetup here on the 25th, I believe, and that's our security-focused global online meetup. And we'll be talking about New Vector and some of our other security solutions. So we'll catch you guys in the community. Thanks, everybody.